Wiring to trees, while sometimes deemed necessary, can introduce a multitude of concerns. Firstly, there is the potential for tree damage. Wires that are stapled or directly attached to the tree trunk can compromise the bark and the cambium layer. This interference can significantly weaken the tree, making it more susceptible to infestations by pests and increase the likelihood of contracting various diseases. Secondly, an electrical hazard emerges if the wires become compromised, either due to the tree's natural growth patterns enveloping the wiring or from external factors such as storms and physical damage. This damage could expose live wires, creating a dangerous situation for anyone coming into contact with the tree or the surrounding area. Thirdly, the aesthetic aspect should be considered. Running wiring on trees can be visually unappealing and can detract from the natural beauty and landscape. Ultraviolet wiring is designed to resist sunlight damage and is usually specified for outdoor applications. However, it is important to understand that even ultraviolet-rated wiring will degrade over time when exposed to the elements, especially when it is directly stapled to a tree trunk. Using conduit to protect the wiring up to 3 feet from the ground is generally a good practice. It provides a physical barrier that can help prevent damage from lawnmowers, weed whackers, or other landscaping equipment. However, it is important to recognize that the wiring is still exposed once it exits the protective conduit. If wiring to a tree is unavoidable, consider following these best practices. Firstly, opt for a tree-friendly wiring system. These systems are designed to wrap around the tree trunk without penetrating the bark. This method minimizes the potential for damage to the tree-sensitive layers. Secondly, run the wires vertically up the tree trunk instead of wrapping them horizontally around it. Vertical wiring minimizes the circumference contact, further reducing the risk of damage to the cambium layer as the tree grows. Thirdly, utilize non-invasive fasteners to attach the wires to the tree. Screw-in tree hooks or similar devices offer a secure attachment point without requiring staples or other methods that penetrate the bark. Fourthly, establish a regular inspection schedule for the wiring. Regularly checking for any signs of damage, wear, or potential problems will allow for early detection and prompt replacement of any affected sections. Considering alternative solutions to wiring to trees can mitigate the risks altogether. Firstly, using a tree crossarm. Installing a tree crossarm or branch extender can provide a stable support for the wiring without causing any direct harm or damage to the tree itself. Secondly, burying the wiring. If feasible, burying the wiring underground eliminates both the potential hazards associated with exposed wires and aesthetic concerns. Be sure to adhere to local electrical codes and safety regulations when burying electrical wiring. Thirdly, consider the use of wireless devices. Exploring the use of wireless devices such as solar-powered floodlights or motion sensors can completely eliminate the need for any wiring on the tree. These devices offer a convenient and safe alternative while reducing the risk of electrical problems and preventing damage to the tree. When dealing with existing wiring situations where the ultraviolet wiring is starting to grow around the tree, it is strongly recommended to replace the wiring. You can use a tree-friendly system or consider one of the alternative solutions. Regular inspections of any outdoor wiring are critical to ensure safety and to prevent potential hazards. Look for signs of wear, damage, or rodent activity that can compromise the integrity of the insulation and conductors. Always disconnect the power before working on any electrical wiring. This simple precaution can prevent accidental electrical shock and ensure your safety. Consider hiring a qualified electrician to perform the work. If you are uncomfortable or unfamiliar with electrical wiring, it is always best to hire a professional. A qualified electrician has the knowledge, experience, and tools to safely and properly install or repair electrical wiring. Always follow the National Electrical Code, referred to as NEC, and local electrical codes when working with electrical wiring. These codes provide detailed guidelines for safe and proper installation methods. When selecting wiring for outdoor use, be sure to choose wiring that is rated for outdoor use and is suitable for the specific environment. Ultraviolet resistant wiring, wet location wiring, or direct burial wiring may be appropriate depending on the application. When using conduit to protect wiring, be sure to use the appropriate type of conduit for the application. Electrical metallic tubing or EMT is suitable for above-ground applications, while rigid metal conduit or RMC or PVC conduit is suitable for underground applications. When making electrical connections, be sure to use the correct type of connectors and to properly tighten them. Loose connections can cause overheating and electrical fires. When working with electrical wiring, always wear appropriate personal protective equipment or PPE, such as safety glasses, gloves, and insulated tools. Be aware of the potential hazards associated with electrical wiring, such as electrical shock, arc flash, and electrical fires. Take the necessary precautions to protect yourself and others. When in doubt, always consult with a qualified electrician. It is always better to be safe than sorry when working with electricity. The NEC provides specific guidelines for the installation of outdoor lighting. These guidelines cover topics such as the type of wiring to use, the depth of burial for underground wiring, and the grounding requirements for outdoor lighting fixtures. When installing outdoor lighting, be sure to follow these guidelines to ensure that the installation is safe and compliant with electrical codes. The NEC also provides specific guidelines for working around trees. These guidelines cover topics such as the clearance required between electrical wires and trees, and the methods for protecting electrical wires from damage caused by trees. When working around trees, be sure to follow these guidelines to ensure that the installation is safe and compliant with electrical codes. Remember, working with electricity can be dangerous, so it is important to take the necessary precautions to protect yourself and others. Always disconnect the power before working on any electrical wiring, and always consult with a qualified electrician if you have any questions or concerns. The use of ground fault circuit interrupters, or GFCIs, is essential for protecting electrical circuits in wet or damp locations. GFCI devices constantly monitor the current flowing through a circuit, and if they detect an imbalance, they quickly trip the circuit, preventing electrical shock. GFCIs should be installed in all outdoor locations, including those where wiring is run to trees. Surge protection devices, or SPDs, can protect sensitive electronic equipment from damage caused by power surges. Power surges can occur due to lightning strikes, utility switching, or other electrical events. SPD should be installed at the main electrical panel and at any subholes that feed sensitive electronic equipment. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. All electrical equipment and wiring should be properly grounded in accordance with the NEC and local electrical codes. When burying electrical wiring, it is important to use the correct type of wiring and to bury it at the proper depth. Direct burial wiring is specifically designed for underground use and is resistant to moisture, corrosion, and physical damage. The NEC specifies the minimum burial depth for different types of wiring. When running electrical wiring through trees, it is important to protect the wiring from damage caused by the tree's growth. This can be done by using conduit, flexible metal tubing, or other protective measures. The NEC also specifies the minimum clearance required between electrical wires and trees. When installing outdoor lighting, it is important to use fixtures that are rated for outdoor use and are suitable for the specific environment. Outdoor lighting fixtures should be weatherproof and resistant to corrosion. The NEC also specifies the requirements for the installation of outdoor lighting fixtures. When working with electrical wiring, it is important to use the correct tools and equipment. Insulated tools are essential for preventing electrical shock. Voltage testers can be used to verify that the power is off before working on any electrical wiring. The NEC provides detailed guidelines for the safe and proper installation of electrical wiring. These guidelines cover topics such as the type of wiring to use, the size of the wiring, the methods for protecting the wiring, and the grounding requirements. When working with electrical wiring, it is important to follow these guidelines to ensure that the installation is safe and compliant with electrical codes. The NEC is updated every 3 years, so it is important to stay up to date on the latest changes. The NEC is available for purchase from the National Fire Protection Association, or NFPA. In addition to the NEC, there are also local electrical codes that may apply. These codes may be more stringent than the NEC and may address specific local conditions. It is important to check with the local authorities to determine which electrical codes apply in your area. Working with electricity can be dangerous, so it is important to take the necessary precautions to protect yourself and others. Always disconnect the power before working on any electrical wiring, and always consult with a qualified electrician if you have any questions or concerns. Remember that electrical safety is everyone's responsibility. By following the guidelines in the NEC and local electrical codes, and by taking the necessary precautions, you can help to prevent electrical accidents and ensure that electrical installations are safe. The choice of conductor material is crucial for electrical wiring. Copper and aluminum are the most common choices, each with its own set of properties. Copper offers excellent conductivity and is highly resistant to corrosion, but it is more expensive than aluminum. Aluminum, on the other hand, is lightweight and cost-effective, but it has lower conductivity and is more susceptible to corrosion. When selecting a conductor material, it is important to consider the application, the environment, and the cost. The ampacity of a conductor is the maximum amount of current that it can safely carry without overheating. The ampacity of a conductor depends on its size, material, and insulation type. The NEC provides tables that list the ampacity of different types of conductors. When selecting a conductor size, it is important to choose a size that is large enough to carry the expected current load. Voltage drop is the decrease in voltage that occurs along a conductor due to the resistance of the conductor. Voltage drop can cause equipment to malfunction or not operate properly. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. When selecting a conductor size, it is important to consider voltage drop. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When an overcurrent occurs, the overcurrent protection device will trip, interrupting the flow of current and preventing damage to the circuit. The NEC specifies the requirements for overcurrent protection devices. Grounding electrode systems provide a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. The NEC specifies the requirements for grounding electrode systems. Bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault current. Bonding helps to prevent electrical shock and to ensure that overcurrent protection devices will trip properly. The NEC specifies the requirements for bonding. Wiring methods are the different ways that electrical wiring can be installed. The NEC specifies the requirements for different wiring methods. Electrical boxes are used to enclose electrical connections and to provide protection for wiring. The NEC specifies the requirements for electrical boxes. Cable trays are used to support electrical cables. The NEC specifies the requirements for cable trays. Raceways are enclosed channels that are used to protect and route electrical wiring. The NEC specifies the requirements for raceways. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. The NEC specifies the requirements for electrical equipment and wiring in hazardous locations. Special occupancies are areas that have unique electrical requirements, such as hospitals, schools, and data centers. The NEC specifies the requirements for electrical equipment and wiring in special occupancies. Emergency systems are electrical systems that are designed to provide power in the event of a power outage. The NEC specifies the requirements for emergency systems. The NEC also covers low-voltage systems such as telephone, data, and fire alarm systems. The NEC specifies the requirements for low-voltage systems. The NEC is a complex and comprehensive document, but it is essential for ensuring electrical safety. By following the guidelines in the NEC and by taking the necessary precautions, you can help to prevent electrical accidents and ensure that electrical installations are safe.